Today we are going to be looking at factoring expressions. So this is the same thing as doing the distributive property backwards is how I like to think about it. So we're going to be given an expression, and we're going to need to make it look like the distributive property needs to happen. And to do that, we find the greatest common factors of all the numbers in the expression and factor that number out. So let's look at an example. 4x plus 20. To do this, I start by listing all the factors of my numbers. So I have 4 and 20. So for 4, I know I have 1 and 4, because 1 times 4 is 4. And then I have 2 times 2, which is 4. So 1, 2, and 4 are my only factors of 4. And then for 20, I have 1 and 20, 2 and 10, 4 and 4. No, 4 and 5, sorry. Yeah, got confused. So all of my factors of 20 are 1, 2, 4, 5, 10, and 20. So I look and see what is the biggest number they have in common. Well, they both have a 4 in their list. So I know that will be my greatest common factor, and that's the number that I factor out. So to do this, I write a 4 out front of parentheses. And then I have to ask myself, 4 times what is going to give me 4? Well, that would be 1, so that's why I just have x there by itself. Because remember, 1 can be invisible when multiplying. And then I ask myself, 4 times what gives me 20? And I know that's 5. So I'd have to put a 5 there. Because then if I were to factor this 4 out to the expression, that would be 4x, and that would be plus 20. And that's what I want. So you see how it's kind of the opposite of what we were doing yesterday, opposite of the distributive property? All right, so in this problem, they were asking, what is the length of the pool? So if this is our 4, this is going to be our x plus 5. So the length is x plus 5. All right, let's try some more. It says show 2 different ways to factor 4 and 28. So the first thing I do is list my factors of both of my numbers. So 4, we know that's 1, 2, and 4. And then for 28, I know I have 1 and 28. I know I have 2 and 14. Oh gosh. I know I have 4 and 7. Sorry, I was trying to figure out how I wouldn't run out of room, but not 5, nothing times 6, and then I'm already back at 7. So now I'm done. Now I try to see what's my greatest common factor. And again, my greatest common factor is 4. So I'm going to factor out a 4. So I put a 4 in front of my parentheses. And I have to ask myself, 4 times what gives me negative 4? Well, that's a negative 1. And then I always keep my variable. And I don't really have to write the 1, right? Because anything times 1 doesn't change. So I can really just keep that as negative x. Then I ask myself, the 4 times what is going to give me negative 28? Well, that's 7. Negative 7. And the reason they asked for 2 different ways is since these are both negative, what I can do is I can actually factor out a negative 4. And negative 4 times what gives me negative 4x? Well, that's just 1x or x. And then negative 4 times what gives me negative 28? Well, that's positive 7. So that's two different ways where I will get my same expression if I were to use the distributive property on the ones I factored out. So they want us to take the 1 over here, 6x minus 18 minus 12y. And they have already told us that our greatest common factor is a 6, because that's what they pulled out. But they want us to pull out a negative factor, so a negative 6. So negative 6. Well, negative 6 times what would give me positive 6? Well, that's actually a positive one, because remember, two negatives make a positive when we're multiplying. So I can just do negative 1x or negative x. And that way, those two negatives would make a positive. Then I need negative 6 to get negative 18. Well, that would be positive 3, because I need different signs to make a negative. And then negative 6 times what gives me negative 12. Again, that's going to be a positive 2. Keep the y, because different signs make a negative. All right, I know this one's a little harder. But what I do want you to do is try 2 on your own. See if you can figure out where she made an error and if you can factor it out on your own. We will go over and try some more of these in class today.